Hi, myself Hari Krishnan and my batch members Gautam Raj, Chadurvedi and Sohail Ahmad. Our project is about auto guidance aircraft landing system which is guided by Srinath sir. Our, pro- our abstract. Auto, Automatic advanced landing system is most essential and required for the most modern airports to reduce downtime of activities and to improve quality air traffic. We would like to integrate the existing system which is widespread in the airport today and leads to misguidance of aircrafts. We would like to develop an angular position of an aircraft from mid of runway, demonstration of diagonal antenna function and rotation of technique of radars, landing angle of an aircraft, ambient parameters and metrology to present economic affordable solutions for perfect takeoff and landing system for airport with physical ambient condition of the airport with audiovisual networking. Next, objective. Objective to reduce the downtime activities air traffic is more in modern airports. It guides the aircraft to land the takeoff on the right path. It avoids confusions among the pilots and ATC. ATC is nothing about air traffic control. Now we move on to existing system. In our present days, in our India Instrument and Landing System (ILS) used so that they need a human to operate from airport. Whenever aircrafts are departure or arrives to an airport, first a human needs to check for meteorology, runway conditions, etc. Then after they can allow to arrive or departure. Currently in India, we have an instrument landing system which is ILS-3. Then we can move on to proposed system. In this, we have created a network between airport and the aircraft, which updates to airports and aircraft nearby regarding weather reports. In case of poor visibility conditions, the pilot is guided with a landing parameters and a local weather on his console, so that a landing can make without looking at a runway. Then all these processes are done with a human help, and system is called a zero visible landing, so that we can land while zero visible. Let's we move on to block diagram. Block diagram. In this block diagram, we have two blocks, which is airport and aircraft. Which this is a basic block diagram for ALS. Then demonstration. Normally we have two parts, which is airport and aircrafts. In this airport, we have three major parts. One is radar, and another one is metrology, and another one is an ATC. In this temperature and humidity, we are use the temperature for a thermistor to find atmospheric, room temperature and humidity. They convert temperature into mils or oats. With these values, we are converting into 0 degree Celsius room temperature by manual calculation. For humidity, one thermistor is inserted in water or other. Next, we can see wind speed and wind direction. Wind speed and wind direction is nothing but it is just a simulation, which is normally measured by a switches. Wind is measured by basically by fan. Next, we can see fog and visibility. Fog. If IR sensor are used, IR sensor consists of IR emitter and IR detector. Positive voltage is given to IR emitter. Using this voltage, it transmits IR rays continuously. IR detects, collects these rays. Then we can see stepper driver. Stepper driver is consist of buffer, optocoupler, P driver, and driver. Buffer interface 8255 with a high level circuits for driving high current loads. Optocoupler, it consists of opto emitter and phototransistor. And optocoupler is essentially to prevent the computer from hazardous conditions like voltage transistors, back EMF and high voltage spikes. These are the landing techniques for ALS, aircraft landing system. First one, wind direction. Wind direction, it is a midpoint from a run point which has 2.8 kilometers. When a flight which has 2.8 kilometers, and when a flight reaches in the midpoint, and the fan is used to find the wind direction.
This is the landing sensors, which is used to detect the movement of a lever which is present in the aircraft. Where this four up, down, left, right indicates the aircraft lever. Where when the aircraft lever is moved upwards, this sensor will detect the upward direction and shows here by using the Visual Basic. This is the ambient conditions where metallurgy department will do this process, where we have a separate sensors for each ambient condition like temperature, humidity, wind speed, fog, and visibility, where each sensor will detect the values, and these values are noted in this Visual Basic. Advantages: there might be a chance of accident due to abnormal position of a flight during landing. By checking the position of lever, the chance of accident can be reduced. By using this project, ATC can monitor and control the air traffic more efficiently. With the help of the monitoring ambient parameters like temperature, humidity, wind speed and its direction can avoid confusion in arrival and departure of the aircraft.
This is the kit which is presented in airport. This is the ATC. This one is the ATC. This is an optocoupler, and this is used for wind speed. And this will be measuring the fog, and this will be measuring the visibility. And these two are used for temperature sensor. And this is the angular rotation, and this is the stop. This is the ATC, and through this, if an indication is coming from aircraft, and this will regulate the pilot to land through the various dimensions from the aircraft.
This is the receiver kit which is present in the aircraft. Now this indicates the navigation and direction of the aircraft. This is the lever which by movement of this lever is detected by this sensor, and this is transmitted to the airport, where this movement is detected and sends through the wireless communication.
This is the flight kit and this is the airport kit. In this flight kit, when we move on to the upper button, automatically it stimulates from the airport, it moves to the upper level. Then if we move on to the lower level, when we navigate, when the navigator is downwards, it will show through the downwards. If the navigation rotates in the left or right, it will show in the output and from to the airport in a left and right.
This is the kit which is present in the airport, where this indicates the wind direction. This shows the wind direction, and this is the visibility which will measure the visibility, and this is the fog sensor which will measure the fog, and this all readings are noted in this ambient conditions. And this is the diagonal antenna, and this is the angle of rotation, where by using this we can land the aircraft in the right path in the runway. This is the radar which rotates and finds the aircraft. And this is the output of this ATS, aircraft landing system.